All right, here we go, 3.2. Let's learn some product and quotient rules. So check this out. If I'm multiplying two things here and find the derivative, we actually can do this with the power rule like last time. So let's go ahead. I want to find the derivative. So if I'm finding the derivative, before I go ahead and find it, we're going to rewrite it. So you could double distribute here. We could multiply this out. Some people like to say FOIL, however you want to do it. You could say, oh yeah, if I multiply it out, I get 2x squared minus 5x plus 8x minus 20. So I can rewrite it, and then you can take the derivative of this, and you get what? You get 4x. If I combine these middle terms, I get 3x, so it's plus 3, and then the 20 disappears. So this is the derivative, 4x. Whoa, I missed there. 4x plus 3. Let's save this bad boy. Can we save this thing? So I'm going to bring it over here for now. I know that's the derivative. Is there a rule to help us with this? Sure, it's the product rule. So we're multiplying two things. It's going to be the product rule. Let's do it again using this product rule. Get rid of that bad boy. And what does this say? This says if I'm taking the derivative of something times something, so this is u times v. So I've got an expression here and an expression here. So what am I going to do? I'm going to take the derivative of the first times the second plus the first times the derivative of the second. Ooh, that's a mouthful. Let's just do it. It's much easier to see. So u, if you want to write it all out, u is x plus 4. What's the derivative of u? Well, it's just 1, isn't it? The derivative of that. And then I'll use a different color here. V is 2x minus 5. What's the derivative of v? It's just plain old 2. So now let's put this all together here. So it's the derivative of the first, so it's, boom, it's 1, times the second, the v. This will be 2x minus 5. And then I'm going to add the original, x plus 4. It's got to be in parentheses. The whole thing's in parentheses. And what is this? 2. Excellent. So if I clean this up a little bit, distribute the 1, you get 2x minus 5. Distribute the 2 over here, you get 2x plus 8. Combine like terms here, and what do I get? 4x plus 3. So that is the derivative. And they match. Yay, I got it right. So you may be looking at this and say, well, Mr. Bruss, guess what? That took more work. Yeah, I showed every single step and was to show you how it worked. And that's, maybe you do want to multiply it out there. But do you want to multiply it out here? Now it gets trickier. You could do some kind of crazy distribute, or we can go ahead and use our product rule. Can we steal that? Can I get that rule? All right, so here I'm going to want to use the product rule. There it is, boom, right there. And a lot of times, a lot of books will do this the other way. They'll show u v prime plus the other way. So if you've seen a book the other way, that's okay. I like it better this way, and it's going to come up when we take a look at the quotient rule. So what is in this case? The first term is u. The second one is v. If you want to write all these out, you can. This will help on actually not till chapter 10, but we'll get there someday. The u prime. So the derivative is u. Or I'm sorry. Here's the first function is u 3x squared plus 2x minus 3. Find the derivative. I get this. V's not so bad. It's just x minus 1. So v prime is just 1. And then put it all together. We've got the derivative of the first, 6x plus 2. Boom, times the second, which is x minus 1. And we're going to add to it what? The original function, 3x squared plus 2x minus 3. And it's got to all be in parentheses. And then the derivative, luckily that's 1. So there still is some multiplication here. We can't avoid multiplying a little bit. We're going to have to do your little FOIL or double distribute here. So we are going to have to multiply this out and say, okay, it's 6x squared minus 6x plus 2x, boom, minus 2. But again, that's probably better than writing that all out. In some cases, we can't even multiply it. We have to use this rule. Luckily, this all stays the same. And now it's just a matter of combining like terms here. So I've got what? 9x squareds, and how many x's? Minus, plus, and plus. Is that minus 2x? Negative 6 plus 2, and then do your numbers. We've got minus 5. So the derivative of this one is 9x squared minus 2x minus 5. Awesome. Why don't you pause it, try the next one on your own, and see how that goes. All right, so hopefully this is the final answer down here as far as you can simplify it. A couple of things here. Remember, pi is a constant, so it disappeared. So hopefully this is the first step, the derivative of the first times the second, plus the first times the derivative of the second. Then I did a lot of simplifying there. You can check it out. And the blue one here is when I just got it unsimplified, and then you got to get rid of those negatives. So hopefully you got that same answer. And that's it. That's the product rule. Awesome. Can you do this to evaluate? Sure, we can do the same thing. I can come over here and say this is U and this is V, blah, blah, blah. But you don't always have to do it when you see product. So sometimes it's easier maybe not to do it. Remember back to the power rule where we got to rewrite? If I rewrite this as x to the 1/2, the square root, now check this out. This is something I do not mind multiplying at all. This is just distributive property. So if it's just distributive property, I'm going to go ahead and multiply this out. And really, if I rewrite this, remember what's the rule? When you multiply, you add the exponent. So if I do this, 1/2 plus 2 is 2.5, or that is 5/2, and then minus 3x to the 1/2. So don't be freaked out by the fractions. You're just adding the exponents. Then, now I'm ready to rock and roll. Now I can actually take the derivative. So what is this? It's going to get kind of weird looking here, but you're going to get 15/2 x, subtract 1. So this is just power rule. Subtract the 1 from that, and what do you get? 3/2? And minus 3/2 x to the negative 1/2. This is great. Let's go ahead and clean this up a little bit because I'm trying to evaluate what it's for. I'm not quite ready for that yet. Let's go ahead and say move the x to the bottom. Ooh, this is a long one here. So we got 3 over 2 times the square root of x. There it is, finally. Now I'm ready to rock and roll and evaluate when x is 4. Something like this, plug 4 into the actual equation. So I'm looking at, I probably should have written this as what? The square root of x to the 4th, or x cubed. Let's go ahead and rewrite it like this. So that'd be 4x cubed all over 2 times the square root of 4. So not the friendliest final answer here. I make up some good examples sometimes. But we can do it. 4 times 4 times 4 is 64. Divide that by 2 is 32. 15 times 32 is 480. Now that's one I expect to be able to do in your head. That would probably be a calculator one. On bottom, this would be minus 3 over the square root of 4 is 2, so 3/4. So the final derivative would be, you can make, I'm going to make this a decimal if that's all right, minus the 3/4, 479.25 would be the derivative. And why are we finding derivatives? So the derivative is the slope at a point, it's the slope of the tangent line, and is the instantaneous rate of change. Excellent. So derivative is so important. So important. All right, so that's the product rule. So we'll practice some of those. How about this? Maybe you can guess what this is. That's right. We're divisioning. You can't divisioning. We're dividing here, and dividing means quotient rule. So there is the quotient rule, and check it out. Look at the top of this thing. It's nearly identical. That's why I like to write it like that. It's the same thing, but the top turns to a minus, and then on bottom is v squared. So when I'm doing this, so the function on top is u, the function on bottom is v. And if you want to write this all out, you do not have to write this out when you're doing your practice. If it helps you organize your thoughts, go ahead and write it out. If you can do it just straight to your paper, that's cool too. So this will be 2x plus 1. Wait a minute, I wrote that wrong. Woo! Look at me trying to help, and I mess it up. V prime would be what then? 2. So I've got the top function and their derivatives. Now it's just a matter of plug and chug. So I'm going to say it's the derivative of the first. It's u prime. I love it when it's 1. And then we're going to times it by the v. Put it in parentheses. Parentheses are really important in this one because we got this negative sign. So it's subtracting that whole quantity of u, the top term. So, and then it's the derivative of the bottom term, which is 2 in this case, all over the derivative of the bottom function there. So it's boom, this right here. Excellent. So these are a little bit more to clean up here. So when I distribute that 2, it's just 2x plus 1. Distribute a negative into this, and maybe you want to distribute the 2 at the same time. It's negative 2x plus 10. That's a killer right there. That is going to give you a negative times a negative is a positive. I went ahead and distributed the 2 as well, just so I have to write all steps. Sometimes I get a little lazy. The bottom I usually leave like this. So we're looking at the derivative, but that top still cleans up. Let's take it one more step here. The bottom, I'm not going to FOIL that out or expand that out, but on top, sometimes some nice things happen. What happens here, the 2x's actually cancel. So this is kind of cool. I'm left with 11 over 2x plus 1 quantity squared. Boom, there it is. So if you see a product, or if you see a quotient, chances are you can use quotient rule. Boom, nailed it. All right, 2 more examples of this. Man, we are cruising. So I look at these and I see two quotients, so I'm thinking quotient rule, but there's a huge difference. Same numbers in these, but there's a huge difference. Look at number one. We're going to do this together. I'm going to go back and rewrite. So a lot of times I don't like to do this whole long quotient rule thing. Too much work for me. So check it out. This is actually two fractions, isn't it? You can split this into 3x over 2x squared and 1 over 2x squared into two separate fractions. You can only do that when there's one term on the bottom. Can I do it over here? No, I can't split this up. So this one's going to be quotient rule. This one's not. Once you have it split up, things will start to cancel, I hope. That cancels out one of those. Nothing really over here. I'm going to rewrite it one more time. So it's really 3 halves x to the negative 1. Remember, we don't want that in the denominator. Plus 1 half x to the negative 2. Now I am ready to differentiate. Boom. Take the derivative, and I'm looking at negative 3 halves x. Drop that power 1, and this goes back to the other one. So I'm going to mix some old ones in there. So I'm not going to give you in the practice just a bunch of product and quotient. You can do it for them, but there's some that you can rewrite. It will save you some time. But as long as you get the right answer, that's what it's all about. So let's just rewrite this, simplify it out to make it look good. So we got boom, and that'll be 1 over x cubed. That is the final simplified answer. Why don't you pause it and try the next one on your own. Good luck. All right, here we go. So I broke down u over v and plugged it in right there. So you can double check the work here. You want to pause it and look at it. But once you do it, clean it up. This one wasn't too bad. I got a derivative of 6x squared plus 4x all over that quantity squared. We're not going to break that bottom up. We're going to leave it just like that. All right, moving on. So let's do some applications. Remember all the things about derivative. All right, so here I have a function here in blue, and if we take a point on this function, we're going to look at the derivative. So what does the derivative mean? Well, the derivative at this point is the slope at this point. So what's great about that is that's going to give us the slope of the tangent line. And this is so important because the slope of the tangent line is the instantaneous rate of change. So if you look at I went ahead and graphed the tangent line there. If you look at that, the slope of that is positive. So if I go ahead and kind of animate this point, it is a positive increasing function until here. Boom, all of a sudden, now I'm looking at a horizontal tangent line, which, as you can tell what's happening here, I hit a maximum point. Then if we keep this going, you can see that is a negative tangent line. So what does that mean if you have a negative derivative? Well, it means you are a decreasing function. So in this little area, I'm decreasing again until I hit this point up here. Boom, there it is, another horizontal tangent, and in this case it's actually a minimum point. So the derivative is the slope at a point, it's the slope of the tangent line, and is the instantaneous rate of change. And this is a big one right here. This one is awesome. The horizontal tangent. So remember, if you've got a horizontal tangent, if you've got some function doing something like, I don't know, maybe this is your function, and you've got a horizontal tangent, you know, what does that mean that's going on? So maybe like right here, you can tell the tangent line is positive, right? So that's cool. But what if it's down here at this point right here? What is the derivative? It's horizontal. So it has a slope of 0, and it's indicating these minimum points or these maximum points. These have horizontal tangents. So we're actually looking for max or min. So maybe you've made that connection. We're going to try to find these max or mins. Hugely important. So let's do it. So notice it's the same problem as last time, and I got that same answer from there. I just brought it over here. So if I want to find all the horizontal tangents, what am I going to do? I'm going to set the derivative equal to 0. So to find a horizontal tangent, you're going to take the derivative and set it equal to 0. So I'm going to say 0 equals 6x squared plus 4x all over that thing on the bottom there. So there it is. So all I got to do is solve this. So yeah, this one looks kind of nasty. I picked a hard one to solve here. A lot of times they're pretty easy peasy if it's like a product rule. But a quotient rule, got a fraction. Again, if I want the fraction equals 0, the bottom, I can't even talk. The denominator, the denominator doesn't really matter. It's the top. The top has to equal 0 because what is 0 divided by anything? It's 0. So I don't really care about the bottom. I'm only going to focus on the top. So I need to set the top equal to 0 because I know whatever I get here, divided by 0 divided by anything is 0. So how do we do this? Well, I've got an x squared, so I'm going to hopefully factor. And yes, what can I pull out of this? I can 6 and 4. You could take a 2x out. They both have an x in common and a 2, and you're left with x plus, whoa, not x plus 2. Whew. How about 3x plus 2? So I undistributed there, or I factored out the greatest common factor, and that's the same thing. So I pulled the 2x out. And why do I do that? Well, this is multiplication. So what makes this 0? Well, if x is 0. What makes this 0? Well, if you solve that, should I solve it? I'll solve it. What makes this 0? You got to subtract 2 from both sides and then divide by 3, and you get x is negative 2/3. So we factored to solve here because if this parentheses 0, 0 times anything is 0. If that is 0 out here, 0 times anything is 0. So these are the two places. So if I plug 0 in here, we could check it. You get 0 over 1. And of course, it doesn't matter, the top is 0, and then put in negative 2/3, you get 0. So these are where my horizontal tangents happen at 0 and negative 2/3. Or these are going to be potential max or min points. Fantastic. The final slide already. So now I'm going to go a little notation heavy on these. So we did u and v, but a lot of books use f of x and g of x, those functions you're taking the derivative of. So don't freak out here. Let's see if we can do this. If I'm taking the derivative of a function minus a function, so if I'm finding f prime here, and we're supposed to do it at 4, let's just go ahead and write out what it'll be when I take the derivative. Well, this will be the derivative of it, right? We're allowed to do it around addition and subtraction, so this one's nice and neat. So now if I plug in the f prime of 4, what do I get? I'm really looking at g prime of 4 minus h prime of 4, and I gave you some stuff here. It's all when f prime is 4. It's our goal, and these are all at 4. So the g prime of 4 is negative 2. So the h prime of 4 is 5. So we can find the f prime of 4. What is that? Negative 2 minus 5, negative 7. Excellent. Boom. So this is all notation. I never actually calculated a derivative. I don't know these functions, but I can use the notation to get the right answer. Excellent. You want to do the next one together? So if I take the derivative of this, I'm going to go ahead and evaluate at 4 if that's okay. Kind of skip a step there. So the derivative of this will just be what? H prime of 4. What happens to this 2? He disappears. He's a constant. We don't need him. So what is this really? This is just 5. The f prime of 4 over here equals 5. Love it. Love it. You want to try one? Try one. Pause it. Try it. See how you go on this guy over here. That 2 is just like the constant in front. So boom, you're just multiplying by 2. Fantastic. How about this? This is the tricky ones. I'm going to do these with you here because this is our what? Quotient rule. So if you want to write this out, remember the derivative of the first. We're going to do this so much you're going to have this memorized. Derivative of the first, or derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So that's really what it means. Can we do this with your whole h of blah 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 4? Yeah, I think so. So this will be the derivative of the top, which is h at 4, times the bottom function at 4, minus what? The top function h of 4. And my handwriting is getting bad here. And the bottom is what? The g prime of 4. So the derivative of the bottom all over the bottom function at 4 being squared. So that looks pretty cray-cray, but I think hopefully it makes sense anyway. Let's plug and chug. Let's put some numbers here. So h prime of 4, I cannot look at, is that a g? What, I can't even read my own writing. Let's make that, I hope your handwriting's nicer than mine. The h prime of 4 is what? It's 5, so I got a 5. Then I'm going to times that by the g of 4, which is 3. Oof, let's try that again. 3, let's try that again. 3, there we go, I'll take that 3. And then I got the h of 4 over here, which is negative 1, and I've got the g prime of 4, which is negative 2. So really write this out nice and neat, hopefully neater than me. Keep it organized, and then it's not too bad. On bottom is just 3 squared. Let's clean this up a little bit. It looks like, I'm going to write over here by our thing, the f prime of 4 is going to equal what? 15 minus, that's a plus, but minus 2, so I'm looking at 13/9. 13 over 9. I like that one. That was fun. Woo-hoo-hoo. Guess it depends on what your definition of fun is, but I enjoyed that one. All right, let's do a little product rule. This is the last one. I mean, this is a short video. I like this. So I'm going to try to do it the first times the second. I'm even going to skip the u and v. If you like the u and v, write out, but check this out. I know the rule is the derivative of the first function times the second function plus the first function times the derivative of the second function. U prime v plus uv prime. All day long, man. All day. For some reason, I didn't put the 4 in here. Let's put the 4 in there. And let's clean this up and finish it up. So g prime 4, we're looking at negative 2. We're going to times that by the h of 4, which was what, negative 1. We're going to add that to the g of 4, which is 3, and the h prime of 4, which is 5. That 3 is just killing me. I'm going to let it ride, though, because we're almost done here. This will be what? Negative times negative positive plus 15. 3 times 5, 15. We are looking at, let's write this out proper, f prime of 4 equals 17 for that final answer there. Boom, nailed it. We are done and done. Try these. If there's not enough in the packet for you, go straight to the corrective. There's a bunch in there. You can practice these all day long. If it's flowing, just go on through it. Good luck on the math check. Peace out.